Hi, in this video we are going to see how to multiply two matrices. Okay, let me consider two matrices A and B. I want to multiply these two matrices A and B. If I want to multiply two matrices A and B, I have to check a condition. That is, the number of columns of the first matrix A must be equal to the number of rows of the second matrix B. Then only I'll be able to multiply the two matrices A and B. So let me write the condition, that is number of columns of matrix A must be equal to number of rows of matrix B. So only if this condition is satisfied, we'll be able to multiply the two matrices A and B. So always we have to take the number of columns in the first matrix and number of rows in the second matrix, and they must be equal. So in case, what if they are not equal? I mean, the number of columns of the first matrix is not equal to the number of rows of the second matrix. So then we'll not be able to multiply the two matrices. And also one more thing is, a matrix multiplication is not commutative. That is, the multiplication of the two matrices A times B is not equal to the multiplication of the matrices B times A. So matrix multiplication is not commutative. Okay, now let's look at some examples. Here I have multiplication of two matrices. Okay, so before we start multiplication, so first we have to check the condition that I have told you on the previous page. That is, let's consider the number of columns in the first matrix. So 1 and 2. There are two columns in the first matrix, and number of rows in the second matrix 1 and 2. So the number of rows in the second matrix is 2. So the number of columns in the first matrix and the number of rows in the second matrix are equal. So we will be able to multiply the two matrices we have on the board. Okay, so now to multiply these two matrices, I can do it in two ways. One is, I have to multiply each row of the first matrix by each column of the second matrix. Otherwise, I have to multiply each column of the first matrix by each row of the second matrix. So usually we do, usually we take the rows of the first matrix and columns in the second matrix. Okay, now let me take the first row, the first matrix. It has to be multiplied by each column of the second matrix. Okay, now what I'm going to do is, I'm going to multiply the first row of the first matrix by the first column of the second matrix. So when I multiply the first row of the first matrix and the first column of the second matrix, so first I have to multiply the first term over here and first term over here. 2 times 3 is 6. Okay, now let me come to the second term of the first row, the first matrix 5. So when I come to the second term, so here in the second matrix, I have to come to the second term of the first column. So now I have to multiply 5 times 1 is 5. So that is positive 5. So I take the first row, the first matrix, and first column in the second matrix. I multiply the first terms over here and I multiply the second terms over here. That is 2 times 3, 5 times 1. When I take the first term up here, and here I have to take the first term. When I come to the second term, so here also in column, I have to come to the second term. Okay, now I'm going to multiply the same first row, the first matrix, by the second column. Now, when I multiply the first row of the first matrix by second column in the second matrix, I have to write the result over here as a second term, the first row of the resultant matrix. So now let me multiply the first term by first term, that is 2 times 4 is 8. Second term by second term. So 5 times 0 is 0. Okay, now I have to multiply the first row of the first matrix by the third column of the second matrix. So multiply the first element by first element, second element by second element. So when I multiply the first element by first element, that is 2 times 7 is 14. And second element 5 times negative 5 will be negative 25. Okay, now I have multiplied each column of the second matrix by the first row of the first matrix. Now what I need to do is the same thing I have to do for the second row of the first matrix. That is, each column of the second matrix has to be multiplied by the second row of the first matrix. Since I come to the second row of the first matrix, now I have to write the results in the second row of the resultant matrix. So it's the same process. Okay, now let me do the multiplication of the second row, the first matrix, by the first column in the second matrix. It is first element by first element, second element by second element. That is 1 times 3 is 3, and 4 times 1 is 4. Now, I have finished multiplication of the first column of the second matrix by the second row of the first matrix. Now, I have to multiply the same second row of the first matrix by the second column, the second matrix. 1 times 4 is 4, 4 times 0 is 0. So, I get 4 plus 0. Now, I have to multiply the second row by the third column over here. So, first term by first term, that is 1 times 7 is 7, 4 times negative 5 is negative 20. Okay, now let's simplify this. So when I add 6, when I combine 6 and 5, it's 11, and 8 plus 0 is 8, and 14 negative 25 will be negative 11, and 3 positive 4 is 7, and 4 positive 0 is 4, and negative 13, 7 negative 20 is negative 13. So this is the multiplication of the given two matrices. Okay, let's look at one more example. Here we have multiplication of two matrices. So the same thing what we have done in the previous column. It is first we have to check the condition. So the number of columns in the first matrix 1, 2, 3. So there are 3 columns in the first matrix. Let's count the number of rows in the second matrix 1, 2, 3. So there are 3 rows in the second matrix. So the number of columns of the first matrix is equal to the number of rows in the second matrix. So we can multiply these two matrices. So the same thing, we have to take the first row of the first matrix. It has to be multiplied by each column of the second matrix. Okay, when I multiply the first row of the first matrix by the first column of the second matrix, I have to multiply the first term by first term. That is 5 times negative 4. Second term 3 by the second term negative 3. And third term 5 by the third term 3. Okay, let's do this multiplication. Okay, so when I multiply 5 times negative 4 is negative 20, and 3 times negative 3 is negative 9, and 5 times 3 is 15. Okay, I just multiply the first column over here by this first row. Now I have to multiply the second column here by the first row, the same first row 5, 3, 5. So multiply the first term by first term, second term by second term, third term by third term. 5 times 2 is 10, 3 times 4 is 12, and 5 times negative 5 is negative 25. Okay, I multiplied both the columns over here by the first row over here. Now what I need to do is I have to take the second row, the first matrix. It has to be multiplied by each row, each column of the second matrix. So let's multiply the second row over here by the first column. So multiply the first term by first term. 1 times negative 4 is negative 4. And please remember, I have come to the second row of the first matrix. So the result has to be written the second row of the resultant matrix. So when I multiply the first element 1 by the first element negative 4, it will be negative 4. Second element 5 by second element negative 3, it will be negative 15. And 1 second. And third element 0 by the third element over here, 0 times 3 is 0. Okay, now I have finished the multiplication of the row here and the column, the first column of the second matrix. Now I have to multiply the same second row of the first matrix by the second column of the second matrix. Okay, let's do that. First element by first element 1 times 2 is 2, and second element by second element 5 times 4 is 20, and the third element by third element 0 times negative 5 is 0. Okay, let's simplify this. So negative 20, negative 9 will become negative 29, positive 15. When I combine negative 29 and positive 15, the result is going to be negative 14. And 10 plus 12 is 22. 22 negative 25 will become negative 3. And here the simplification of this one is negative 19. And the simplification of this one is 22. So I got the multiplication of the given two matrices.